Hello YouTube, welcome back to my channel. So in today's video we're going to continue with this dealing with missing values. So in the last tutorial we looked at dealing with missing values by filling it with filling the missing values with filling the NA values with the default value. So in this tutorial we're going to look at imputations. So whenever you have a missing value, right, not all your data is missing, right? Maybe you have a very huge percent of your data is missing. Now the worst thing you can do is actually drop these missing value columns, rows. Okay, it's not good to drop these rows because they can highly affect the performance of your model, because your model is only as good as your data. So if your data is much, then your model can learn much and be able to make better predictions. So if you drop missing value columns, then your model is going to lose data and it's not going to learn it sufficiently. So the best thing to do is actually to impute these values. So whenever you have the missing values and you have some known values, figuring out or estimating the missing values from the known values is what we call imputation. So just using the known values to estimate or figure out the missing values, this is what we call imputation. And in machine learning there are two types of imputations. There is a univariate imputations and there is a multivariate imputations. So let's in our case, let me just show you what we did last time. So if you don't watch the last video, you can go back and watch that video. So in the last video we're having the total number of bedrooms missing, right? So one of the types of imputation that you can use for this is univariate imputation, meaning that you only use the total bedrooms column to estimate the values from the total bedroom columns to estimate the missing values. So we use the values of only one column to estimate the missing values of that specific column. That is called as a univariate imputation. And the other one is multivariate imputation, which is the contrast of multivariate imputation, whereby instead of using just the column that you have missing value in, use the known values from the column in which you have missing values to figure out the missing values or to estimate the missing values. Instead, we use multiple columns to estimate the the missing values. So we can use factors such as the housing median age, the population, the household, the other factors to estimate the total number of bedrooms. So we can use different factors such as the location of the house to estimate the total number of bedrooms. Okay, so instead of just depending on only one feature to estimate the missing values, we depend on multiple features to estimate the missing values. That is what is known as multivariate imputation. So let's go ahead and actually start with univariate imputation. So we can do this in sklearn. So I'm going to go ahead and say this from sklearn. Let me get the spelling right. From sklearn.impute, you're going to go ahead and import the following. So you're going to go ahead and import simple impute, which is going to use to do a univariate imputation. So simple imputer, just like this. So once we have that imported, what we now need to do is to create an instance of this. So I'm going to say simple underscore imputer, and this is going to be the following. So I'm going to say simple imputer, and then I'm going to pass in instantiate this. So I'm going to pass in the following. So I'm going to say missing, tell him which missing values you're looking for. So missing values, and the missing values is going to be let me just say the missing values is np.nan, and then the strategy that you want to use. So we can say the strategy is going to be the mean. Let me just say the mean. So this the strategy is going to be a statistical value, and this statistical value is what is going to be used to estimate the value. So in this case, we are going to estimate for the total number of bedrooms, right? So it's going to use the average of the available or the known data points to find the average of the known data points, and it's going to use those average to fill in the missing value rows rather. So if I have a missing value, it's going to replace the missing value with the mean of the known values instead of the total bedroom columns. So you can also use the mode. You can also use mode, and mode is the number with the highest frequency, and you can also use median, which is the middle value. In case you arrange a number in ascending or descending order, the middle value is the mode. The median. So in this case, you're going to use the mean because the mean makes much more sense. So once we have that, you can simply go ahead and make a copy. So you can do df.isNa.sum. So let's check if you have any missing value. You can see we have missing values 207 in the total bedroom columns. So I can do df underscore copy. I'm going to say let me say 4. It's going to be df.copy. Copy, just like that. We are going to copy it into a data frame known as df underscore cp4. So once I have that, I'm going to impute the value. So I'm going to say df underscore cp4, is going to be the simple imputer. So I'm going to say simple underscore imputer, which is the instance right here. So you can even copy it, and you can just simply paste it here. And then you're going to do .fit underscore transform. So you're fitting and transforming at the same time. .fit transform, and then you're going to say df. You're going to say total bedrooms, and then you're going to do values, and then reshape. So I'm going to reshape this. So I'm going to reshape this, and I'm going to pass in -1, okay. So once I have that reshaped, I can simply run this. So this actually needs to be assigned to the bedrooms, or the bedrooms column. So I'm going to say total underscore bedrooms, just like this. So once I have that done, and I do df underscore cp for head, you can see we have that data frame right there, and I can do the df underscore cp for is na this na.sum. Say if you have any missing values, and you can see we have no missing values, and all the missing values have been replaced by the mean of the total number of bedroom columns, okay, because the strategy that you're using for simple imputer is just the mean strategy. So you can also use the other statistical methods. You can go and research more about which statistical method that you can use on Google. You can just search for sklearn imputer, and then you read more about it. So yeah, that's all that univariate imputation is. Means you are going to figure out or estimate the missing values using only one feature column instead of using multiple feature columns. In this case, we are going to use the feature columns in which we have missing values. In this case, we have used the mean of all the known values. So great. And the second type of imputation that you can go over is known as the multivariate imputation. So multivariate imputation, we can implement this using the iterative imputer from sklearn. Okay, so this one, instead of using just a specific column, only a single column like the way we did for simple imputer, it uses multiple columns to figure it out. So let's go ahead to figure out the missing values, for the appropriate values for the missing column. So we need to go ahead and import the following. So I'm going to say sklearn dot experimental import enable underscore iterative underscore imputer. So we have that. Make sure that you import that. So sklearn experimental, I think I got the spelling of experimental wrong. I missed an e here. Experimental, yeah. So once I have that imported, I'm also going to go ahead and say from sklearn dot impute, we're going to import the following. So we're going to import the iterative imputer, just like that. So once we have these two imported, we can go ahead and use the iterative imputer. So let's first of all create an instance of this. So I'm going to say it imputer, and this is going to be the following. So you're going to say iterative imputer. You can simply go ahead and copy this and then just paste it here. So you can just select this and paste it here, and then in here we need to provide the max iteration. So max iter, and the max iter is going to be 10. The reason we're providing the max iter is because this does things in a Rubin wise loop, like kind of like in a round Rubin, right? So it does this iteratively. So we have to use the max iterations. You can say that max iterations is 10, and then I'm going to leave a link in the description to the official documentation of this so that you guys can read more. Okay, so you can also say the random underscore state. I'm going to say the random state to be 0, and you can use the random state to be 0 in case you want to for repetition, right, to repeat what I just done. So I'm going to say max underscore imputer imputer. This is going to be the following. So I'm going to max iter. I'm going to simply going to fit and transform this. So I'm going to first, let me just go ahead and actually fit first. So I'm going to provide in a two-dimensional array. So I'm going to say 10 and then 15, and then I'm going to provide another here, and this is going to be 30 and then 35, and then I'm going to provide in np.nan, and then this is going to be 85, and then I'm going to provide in 70, and then np.nan, just like that. So once I have this, I can simply run this. So once it's done running, I can simply go ahead and try to estimate. So I'm going to have an x, let me say x underscore test, and this is going to be an array. So it's going to be a two-dimensional array as well. So I'm going to np.nan, and then I'm going to have 25, and then I'm going to have another one which is going to be 60. This is 60, and then it's going to have np.nan, and then I'm going to have the last one which is going to be np.nan, comma, and then it's going to pass in here 75. So once I have that, I can simply go ahead and fit this. So I'm going to do iter underscore imputer.fit. Though this is going to be transform rather, because we've already fit it right using this data right here. Now we're going to transform it. So transform, and I'm going to transform this text one to get the missing value. So we're going to say x underscore test, just like that. So okay, go ahead and run this. Also I got an error dot transform. Okay, let me get the spelling there right. So transform, and you can see it makes the prediction for all the nan values. So the first, let's start by looking at the value that we fit it. You can notice that the values have a difference of 10, right? So this one is 5, and then 15, and then 30, and then 35, and then this one has nothing, right? So in case it wants to predict this one, then it's probably going to predict 80, because the difference is mostly 5, right? And then this one we have 70, and then this one should be 75. So I have fit the model with that the data, and also here I have the difference of 5. So this one should probably be 20, right? So you can see this is 25, so it predicted to be 20, and this is 60, so this should probably be 65, but it predicts about 60. And then this was 75, and it predicted to be about 76, right? So yeah, you can see it's kind of close in making the estimate. So using iterative imputer is more sophisticated than using the simple imputer, because instead of relying on just one column, it relies on multiple columns to make decisions, right? Yeah, so that's how you can talk about the iterative imputer. So that's how we can use iterative imputer. So one little task I'm going to give you: try to use iterative imputer to estimate the total number of bedrooms, and that's your little assignment. So what you're simply going to do, instead of just relying on one of the columns to figure out the missing values, you're going to use multiple columns to figure out the missing values. So try to do that, and try to play with the total number of iterations, right? So you can experiment to see which one gives you a better approximation. So guys, thanks for watching. See you in the next one. If you enjoyed this so far, if you're new to the channel, please kindly consider subscribing to the YouTube channel. Hit the subscribe button, the notification bell, and the like button, and share this video with anyone who you might think might find this helpful. So thanks for watching, and see you in the next one. Keep safe.